Good morning, students. How are you? Welcome to our online class. Today we are going to concentrate on continuation of starters and speed control of three-phase induction motor. This session regarding to 5th semester C18 EE 503 subject code. Subject is the AC motors. Before going to our session, my sincere thanks and courtesy to all authors for sharing their valuable materials in the internet for the sake of students. In previous classes, we have discussed about induction motor construction, its principle, its operation, and based on this we calculated few problems also. At the same time, we have seen starters. What is the necessity of starter? What are the different type of the starters? How these starters can be used in our induction motors from stator side and rotor side. In that, we have discussed in details D-oval starter and auto transformers in previous classes. At a glance, we will see, recall what we have seen previous classes. What is the necessity of starter? That means initially the slip is equal to 1 at standstill condition, I2 is equal to current is a high value. Let us here high to current is equal to S into E2 by R2 whole square plus SX2 whole square under square. This is the current. That means when our induction motor supply is given to here, our rotor is at standstill condition, no speed. That is our rotor speed is equal to 0. Then S value slip is equal to maximum 1. In this case, S is equal to maximum. Then EMF induced in the rotor conductors also maximum. Then current drawn from the supply, whatever the supply, that is equal to I1 also maximum. What is the relation? So I1 current is equal to I component current, I no load current plus I2 dash current. That is the current referred to the primary side. Due to the slip is equal to maximum, this current is maximum, then automatically the current which is drawn from the supply I1 also increased. Then what is happened? This I1 current at starting, I1 at starting, it will draw the current from the supply is nearly 5 to 8 times of full load current. That means if our machine is designed for full load current 10 amperes, then at the starting, but it will draw the current up nearly 50 amperes. If 50 amperes comes into stator winding, but our stator winding is designed such a way that it has some enamel coating, insulation is provided on the insulation on the winding. Then what will happen? So due to the high current, the motor winding heated takes place. Heat will develops. What is the formula? So that is equal I square R T by J. So then current increased 5 times. Then heat also increases based on the time factor. If time increases, then cumulative heat may damage to the our motor winding insulation. If insulation failed or burned, then total winding will burn out. This is the disadvantages if the temperature increases. What is the reason? To increase the current. Hence, we require one device is required to limit the starting current. So, till speed will increase to the nearly 80% of speed is required. During the starting period, I required some devices to control the starting current. So, that device is known as the starter. Okay. So, the starter, what is the starter? Limits the current drawn by the motor at the starter. So, what is the function of starter? The function mainly it can be used to limit the starting current, only starting current. If limits starting current, so small amount of the voltage and current will enough to produce the torque. The torque is try to rotate our rotor. And so not only limit this one, it can be used to start and stop the motor also whenever I require it. Okay, stop. At the same time, we can use this can be automatic speed control also we can use as a starter. Speed control can possible. And finally, so what will happen? So if without this starter, whatever the our motor is connected here for the distribution line, suppose another motor also connected, other motor also connected. So similarly, for example, this take the 5 HP motors, and this is a 7.5 HP motors, this is a 10 HP motors, similarly so on. If this motors switched on at a time, so what will happen? It will draw the more current, it will draw the more current, it will draw the more current. Then automatically, so current increased in the distribution line. If the current increases, what is the formula? Power is equal, power drawn by this line is equal root 3 VL IL cos phi. Then current increased in the distribution line, automatically the voltage decreases. If voltage decreases, what will happen? So instead of 400 volts, the 440 or 400 volts in the line to line, the line voltage decreased to the nearly 300 volts. That means the voltage dip takes place between the lines due to the starting current only. That is unadvisable. Hence, we require the starters. The starters can be used in our induction motors from stator to rotor side. So, I can use the stator side to limit the current. So, what is happen? Here, this is the rotor side. I can use the stator starters can be used at stator side and rotor side. So, in stator side, I can use for the limit the current, voltage and current, and here also I can limit the current. But rotor, there is a possible to arrange the something. What is happened here? So what at a so this is a primary, this is a stator, and this is the rotor circuit representation. Rotor is the short circuited condition in case of the squirrel cage induction motor. Then what will it will draw the current. If applied the voltage, rated voltage, the more short circuit current will flows in this one. So the correspondingly I1 current draws more current. To limit this current, I am required to limit this one. So that purpose I can add some resistance in the rotor circuit initially. Then automatically whatever the current is reduced. If it is reduced, my input current also reduces. So this type of the technique can be used in our slip ring induction motor rotor side. But whereas in squirrel cage induction motor, there is not possible to insert extra resistance such a way that Hence, for squirrel cage induction motors, I can control the speed, control the current from stator side. Okay. So, what are the different starters generally used in our electrical field? So, we can use, one is the DOL starter, direct online starter. A second one is the auto transformer, variac. Third one is the star delta starter, and fourth one is the rotor resistance starter. Rotor resistance starter. And last one is the soft starter. Soft starter means latest starter can be manufactured based on the electronics devices like diodes, transistors, ICs. This is the latest one. It will control all things in a compact way. So, here based on this one, so I can use the dual starter, auto transformer starter, star delta starter, and soft starter in case of stator side, but only rotor side we can use this one. Okay. So, what is happen? So, here main control is it limits the purpose, but first it limits the starting current, At the same time, I required to control this from the overloads, that is the OLR also we required. What is the overload? Release coil. Whenever the motor draws more than the predefined current value for the long time, it has to stop the input to the motor, otherwise the motor winding will burn. And another coil is the similar to the 3-point starter. So, no load coil and no overload coil, no load coil. Similarly, here NL or no load release coil. So, these are the, whenever the voltage comes below predetermined value, then automatically the total supply cut off to our motor. So, these three functions may be inserted in each and every starter. Okay. So, these are the starters. Whereas, in case of dual starter, we are not controlling any type of current or voltage. Remaining starters we can control this all things it contains. So, that is why in dual starter we are not controlling any voltage and current initially. That is why this dual starter is used for only special purpose. The motor rating is less than the 5 HP. If 5 HP motor, so you may be have some doubt. So, 5 HP motor may draws the 50 amperes now, then what will happen? So, the less than 5 HP motors designed and rugged one, it can withstand the high current. So, in fraction of seconds the speed will increases. So, that duration it can withstand such a way that we can provide the insulation of winding. For the more than 5 HP, it is unable to bear that heat temperature. Okay. This is a limitation for dual starter. So, already we have seen everything. Now, coming to our these things once again. So, what is the limited? We can control the limit from the stator side or rotor side by adding the some resistance initially till the rotor reaches its 80% of its speed. Then OLR and NLR, so already we discussed. So, at a glance, so we will see once again every starter, whether it is a dual starter, star delta starter, and auto transformer, a rotor resistance starter, and anything. So, it contains this common thing. What you have seen in previous classes, just at a glance you can see once again how the coil will operate. Okay. So, here what is happened? You can see this one. For example, so there is a one terminals. Okay. So, here what is happened? This is a input R phase, Y phase, B phase. Okay, this is output R phase, Y phase, B phase. Now I connected the one contact, this contacts, and is connected to the common contact. And here I provided the one coil is provided here. Just like is a plunger type coil. It attracts. Okay, now so here what is happen? This terminal, here I connect the one terminal from this one to this one. Okay, so now I connect the this one through my arrangements. So I connected here, you can see, don't confuse. There is a two terminals I can provide it here. So here I can use another color. So this is the two terminals. This is the normally closed. That is a NC coil. We can say NC, normally closed. And here is another normally opened. Normally opened. Okay, that is the NO, normally open. So in our starters, you can see NC is the red color and NO is the green color. For starting purpose, we are pressing the green color. For switched off purpose, we are using the red color. Okay, now you can see here the connection. You can see as electrical students, we should remember the connections. Now what is happened here? Now I connected the coil. So here I connected the one coil. This is connected to our terminal. Now this is connected here. Okay, so here I connected here and I connecting this to this terminal. This terminal. That means so from this two and this two and it is going to here. Okay, so now at the same time I am going to connect this one, this second terminal. I am going to connect it to one phase. Okay, so I am going to connect one phase. For example, I connected this phase. You can see here. So R phase, Y phase. So here I connected the R phase, Y phase, B phase. Now, so I am connecting. So here I can take this one. I can take this from this one. Here, what is happened here? You can see it. Suppose it is closed. R phase, Y phase, B phase. B is connected to here, but it is open. If it is closed, the current is passing through this one, this one, this one, this one, this one, this one, closed, and is going to the this one. So from Y phase to B phase is connected the coil here. Okay, that coil is the line voltage between the B and Y phase. You can see here. Now what is happened here? So these two contacts are opened. It is not closed. If it is moving, the contact moves this direction, then all will close, then continuity circuit. Now it is not closed at this initially. That purpose I can use the temporarily auxiliary conductor. So here I connect the this one from this phase now. So here I connect it. Here temporarily I am going to connect here to this my terminal. Okay, so what will happen? You can see here in the current direction. Okay, now you can see it under normal condition. So what is happened here? Here is the current is coming here. For example, the current is coming here entered here, but here switch is opened. These two terminals are normally open. Supply is coming up to this one, but it is a open condition here, normally open. If I press this direction, what will happen? So it will comes to this one and contact closes. If contact closes, whatever the current comes here, it will goes here. So then the current is coming here. Okay, then it is going here. Normally it is closed and is coming here, entered, and the coil is current is flowing through the coil. It is circuit is closed. Now it is going to this coil. Then it is going to the and is connected to the another phase. That means here our coil is given supply between the, so what is the phase here? B phase and Y phase. So we given the voltage 400 volts, and when circuit is closed, it developed its mechanism. The flux is developed. There is a plunger mechanism. It will move the this contact this side. Piston move inside, plunger mechanism, armature and pull the inside. Then what will happen? So these contacts will move this direction against the spring is provided here. Then once it moves, what will happen? So this current is closed here, and this contact is closed here, this contact is closed here, this contact is closed here. Then our motor will start the current, draw the current, then motor will run. Okay, this is the starting operation. Once if you are pushing this one, there is a spring action. After pushing, then automatically if we remove it, automatically will comes to once again normally open this one. Then what will happen? The circuit is open. Whatever the current is comes is opened. Then how it will excited? Then so you can see here. So if it is closed, then whatever the current is coming here, so this phase is coming now. This phase is closing. So from this one, it is going to here. So then current whatever the closed here, the current is supplying continuously through this one. So then no need of the this one, such a way that the motor is started. This is the one situation. If any problem overloaded here, the motor something overloaded, then what is happened? If overloaded, the current drawn from the motor is increased. Here I can provide the bimetallic strip arrangement. Here is a bimetallic strip arrangements. So what is the bimetallic arrangements? If the bimetallic strips through which the current is flowing, that means here you can see, so this is a bimetallic strip, is connected such a way that this one. So bimetal means two metals, alloy materials are provided. Current is flowing here. Under normal condition, it will draw the current of I is equal, for example, 10 amperes. The 10 amperes flows through this coil, and hence the bimetallic strip is a nature itself. It produces its a heat energy, and the heat energy is increased to the, for example, 36 degrees. So during the 36 degrees, the switch two contacts are closed condition. Once the overload occurred in the machine for the long time, the current instead of 10 amperes, it is drawing the 15 amperes. Then automatically heat developed in this case is increased. Heat is increased. That is a cumulative once time passes. The temperature increased to the, for example, 45 degrees and 50 degrees and 60 degrees. At that condition, what will happen? The nature of the bimetallic strip. So instead of this one, so automatically the contacts which will open. So it will comes to the this direction, just like it's bends this direction. If it's bends instead of closed one, so instead of this one two contacts, then it will move this direction. Then automatically whatever the current is passing through this one, it's a opened here. No current flowing through the this line. Then automatically know what will happen? The whatever the currents coming here through bimetallic strip only here, bimetallic strip only, this strip only. So, this is opened, just like it is a opened. If it is opened, no current flowing through the coil, then what will happen? No flux is developed. It due to the spring action, it is open. It will release the contacts this direction. Then all contacts are opened. Then motor will stop. So, this takes place whenever the motor draws the overload current for the long duration. So, such as that we can provide the OLR, overload released coil. Similarly, suppose I want the low voltage protection I required. The motor is designed for 400 volts 3 phase. Suppose voltage instead of 400, due to the some other faults in distribution lines, the voltage is reduced to the 300 volts only. Then automatically, so here my coil is required the rated voltage. If I given the 400 volts to my coil, so it will produce the flux such as that flux is produced required flux. If I given the 300 volts reduced voltage, then my flux also reduces. So, due to the reduced flux, it is unable to pull my contacts this direction. Okay, so this direction. That what will happen if under normal condition itself, it is a moving, it is attracted towards this one. If the voltage reduces, automatically whatever the flux is induced, that is unable to keep that contacts in the force, then it will release it automatically. So, what due to the spring action, the contacts will move this direction. Then the current connected to the motor is opened here. Okay, such a way that overload and under voltage protection is provided for our induction motors in all starters. These are already explained in revolve starter and auto transformer. So, once again I am explained here. Okay, so this is the basic thing, dear students. It is common for all starters. Okay, now coming to our topic. So, what is our topic? So, you can see your topic is the star delta starter. Now, basic concept. What is the concept here? So, you can see here what is happened. We know that motor has 3 windings. Motor has 3 phase windings: R phase, Y phase and B phase. So, each terminal has the 2 terminals: starting, ending, starting, ending, starting and ending. These 6 terminals is connected in such a way that, so if it is required I can connect it in star, if it is required I connect in delta. Okay. So, here what will happen? Suppose I want to connect the, for example, we take the R phase, this is the Y phase, this is the B phase, these terminals 1, 2, 1, 2, okay, 2, 1, 2. So, we take in the 1, 2, 1, 2, 1, 2, we take in this one. So, all ones are starting and 2 are ending. If I connected the supply to this one, all ones, R phase, Y phase, B phase, then if I shorted this all twos, then it becomes the star connection. In star connection, already we know that here whatever the line voltage VL applied across the 2 lines, 2 phases, then here we are going to get this neutral, then this voltage V phase voltage. So, VL is equal to root 3 into V phase, because here what will happen, this line voltage may not be equal to the phase voltage. Then, so VL is equal to, so root 3 times of V phase. Whereas the current, if you take the IL line current, same current is flowing here I phase. Okay, that means here I line current is equal to I phase current. This is the in case of star connection. Now, coming to the, if these 3 windings connected in delta, for example, this is one winding. So, here one winding, here one winding, here one winding. Okay, so here 1 2 1 2 1 2 is connected. So here connected here connected here connected delta. So then if you are connected here one R phase, here connected is the Y phase, if you are connected here B phase, then what will happen? Here whatever the V line is connected, the same V phase also, but whatever the current I line is connected is here divided two phases. Then so we know that what is the value in delta situation. So whatever the VL line voltage is equal to V phase voltage, but in case of the IL line current is equal to root 3 times of I phase current. Dear students, already these all things are learned in secondary level in 3-phase circuits. Same theoretical this one can be used in our applications in place of 3-phase induction motors, in place of 3-phase induction motors. Same concept, you have already so many problems you have done, star to delta, delta to star conversions and 3-phase circuits you have already done. Same concept we are going to use in our induction motors to reduce the starting voltage. Correspondingly, it reduces the current. Okay, so this concept we are going to use. That means the motor initially, whatever the motor, the terminals, the 6 terminals taken out and is given to the our starter, and starter initially it converts these 6 terminals into star. Then whatever the voltage is given 400 volts, that is due to the star connection of the stator winding, the voltage 400 input if even given after starter, it will use the only 400 by root 3. So what is the value? That is equal to 231 volts appeared across the line to line in the motor. Then reduced voltage is given to the stator winding. Then automatically the current also reduced. The line current as phase current also reduces. Then what will happen? It due to the reduced current, it will produce the torque. The torque is enough to produce the speed of the rotor. If rotor increases its speed, S value decreases. That is required. After few seconds, it reaches to the nearly its speed, N speed, real to N speed, increase to the nearly 80%. Then, so we have to convert delta to star to delta. Automatically we can manual or automatically we convert the star to delta. That means the 6 terminals connected in delta fashion. Then, so what will happen? Whatever the 400 volts is given here, that will totally 400 volts appeared across the stator winding. Then correspondingly it induces the corresponding torque and motor will run at standstill at normal condition, it ready to take the load. Okay, this is a basic concept. That means whatever the winding 6 terminals taken out into our starter, the starter will connect initially in star connection. Then voltage, whatever the voltage, rated voltage is given, input to the motor, reduced to the root 3 times of rated voltage. Then reduced voltage is given to the winding, correspondingly reduces current comes, that will enough to produce the required torque. The torque will rotate the rotor under normal condition. Once the rotor reaches its normal speed, near to the 80% speed, then we are going to shift these windings from star to delta. Okay, so then the required whatever the rated voltage is given in terminals, that is totally applied across the motor winding. That motor is runs under normal condition, it ready to take load. Okay, so this is a basic concept. So based on this one, we are going to see our topic. Okay, so let us see. These are the star delta starter. Okay, so what we have seen here, star delta starter is this figure, you can see it. It has a this is the motor. You connected, you can see the arrangements. So, how the stator connected from star to delta, that purpose we are going to use the mechanisms, switching mechanisms. Okay, we will see later in details. Now, so already we have seen. So, main object is the details about the all things. Okay, now, so star connection, delta connection, and already we have seen just now. Okay, so voltage and current equations in star delta connections already we have seen. Now, different of the starters also we have seen. So, direct dual starter, auto transformer, star delta starter, rotor resistance, it can be already we have seen. Okay, so repeating. Now, you can see this is the one example of the figure. Here what is the, you can see here I can use, this is the MCB. It protects the from overload protection, nothing but OLR. Okay, then so here you can see this is a two arrangements, that this one and this one. Now it is connected such a way that, so it connects one the star and connected the delta. Okay, so here you can see the coil, it's a protection coil, you can see it. Okay, this coil is connected here, and from this one motor connector RYB connected. Okay, at the same time sometimes we can use the timer also. Based on the timer, after 5 seconds or 10 seconds it converted star to delta automatically. So we can say the automatic star delta starter. Okay, so this is a one good example of star delta starter. Now if you inserted inside everything, so whatever we required, MCB single phase and normally closed, normally opened, the timer, everything you can see here. So here you can observe what will happen is a normally closed NC switch. This is the NO switch, green switch for start. This is the timer. After 5 seconds and 10 seconds I will connect to the our coils. So this is a star connected arrangement, then it is a delta connected arrangement, this is the overall protection, and you can see the here also we can use the overload MCB 3 phase, and from this one here given to the our motor terminals. So these all equipments inserted in a box inside this one. So as electrical students I required these circuits only, I don't want this one. Other engineering peoples will see the only outside of this one, this all connections. But as electrical students I want to know that how this connections is given inside the meter. Okay, you can see the practically, this is the circuit diagram. You can see the practical how this MCB is connected and how the timer is connected in the box. If you want to see the enter into the box, you can see here. This is the open box. Same circuit is given here. So circuit for this one, and this is the physical arrangements. Okay, so you can see, dear students, that what is the timer, arrangements, all things were. So what it can do, the function of star and delta starter. This type of the starters are used for motors which are designed to run normally with a delta connected star stator winding, generally delta connected stator winding. At the instant of starting, the two-way switch is thrown to start position, which connects the stator winding in star. Then each stator phase gets V by root 3, that is equal line voltage by root 3 volts, where V is line voltage. This reduces the starting current to 1 by 3 times, and hence the starting torque also reduces. Okay, so you can see this is the another arrangements. Now what will happen here? When the motor speed pickups, okay, so when you can see this is another figure, good figure. So, you can see this one. Here you can see it. What will happen? Here you can see it. Clearly you can understand. This type of the starters are used for motors which are designed to run normally with a delta connected stator winding. Star or delta, but it is preferred for the delta connected stator winding. Now, at the instant of the starting, the two-way switch, you can see this is a two-way switch, you can use here two-way switch, TP DT switch, triple pole double throw switch is thrown to start. So, here the start is equal to, here this is the start, this is the run, thrown to start position, which connects the stator winding in star connection initially. Then each stator phase gets voltage VL by root 3 times. This reduced voltage gives the current 1 by 3 times of current, starting current, and the starting torque also reduced to the 1 by 3 times. Then this torque is enough to rotate our rotor to nearby speed. When the speed peaks, so in the second case, when the motor speed pick up to 80%, nearly, for example, 1500 RPM motor, 80% means nearly 1200 RPM. If rotor speed picks up to 1200 RPM, then this switch TP triple pole double throw switch is thrown to run position, this position. That means run position, which reconnects the motor winding in terminals in delta fashion. Okay. So, here, extremely sorry. So, what is happened? Here what is happened initially? So, this is the, okay. So, this is the start position. This is the start. This is the run position. Okay. Initially what will happen? So, I am going to throw this DP triple pole double throw switch this direction. Then my winding is connected in star. Then what will happen? The voltage VL is reduced to the root 3 times. Then correspondingly our current, I starting current also reduced to the 1 by 3 times of the current. Then what will happen? Due to the less amount of the current, it produces the less torque. This torque is enough to rotate our motor rotor. Then once the rotor picks up its speed nearly 80% of the full load torque, full load speed, that is nearly 80%, then we have to move this from this direction, run position. At that condition, the motor runs in delta fashion. In delta fashion, what will happen? So, whatever the VL is applied, that is also V phase also. That means we are going to give the 400 volts line to our motor winding. Okay. So, that means now the motor is on full line voltage. In making connections, care should be taken such that the sequence of the supply connections to the winding terminals does not change while changing from the star to delta while throwing the DP DT switch. Otherwise, what will happen? The phase sequence changes. That means, suppose you connected the R, Y, B, the motor is running, what is happened? Okay, for R, Y, B, then motor is running this direction. If you connected the R, B, Y, the motor will run opposite direction. So, you have to take care of this phase sequence of motor terminals while moving from the star to delta. Okay. So, these are the things, dear students. Otherwise, what will happen? The motor will run in opposite directions. So this type of the starters are used for motors rating between the nearly above the 5 HP and 20 HP motors. Okay, so these are the basic concept, dear students. Now you can see theoretical part. It has a triple pole double throw switch which connects the stator winding star at start and then in delta while in normal running condition. Hence, this starter is suitable only for motors which are designed to run with a delta connected stator winding. So, this is a, you can see the automatic star delta starter. So, here there is a connections you can see inside the relay connected coil, everything is provided. So, whatever we already have seen, overload release coil and under voltage released coil, everything is provided here. So, timer also provided. So, that means initially, so whatever the connectors inside, if I push the green button, the coil is excited, that is shifted to the motor winding in the star connection. Once after 5 seconds or 10 seconds, the timer will automatically cut off that contactor which is connected in star to delta, divert it. Then delta contactor close the contacts and motor terminals reconnect in the delta fashion. Then motor will continuously run and ready to take the any load. Okay, this is a automatic star delta starter. Actually, the starter you can see here. An actual starter incorporates under voltage coil and overload relay as shown in the previous figure. The wiring diagram of star and delta starter with protective devices is shown in the figure. Okay, so these are the things. Now let us. So once again we can see in PowerPoint. So what is the working of star and delta starter? Initially, when the switch is in the start position, the stator winding gets connected in star. Hence, the V phase is equal to VL by root 3. The voltage across each phase gets reduced by the factor of 1 by root 3 times voltage. Due to this, the starting current also gets reduced. The starting torque also gets reduced. When the motor picks up speed, the switch is thrown to run position. Hence, the stator winding gets connected in delta fashion. Then V phase is equal to V line, that is equal rated voltage of the motor. Each phase of the winding gets a rated voltage nearly 400 volts. The operation of the switch can be automatic by using relays, which ensures that the motor will not start with switch in run position. So that's why its cost is cheap as compared to the auto transformer starter, where it's a bulk in size. Okay, so these are some benefits of automatic star delta starter. Okay, so dear students, so as we know that this is the theoretical part, the in star connection and delta connection already we have seen how the I phase is equal to, that is equal to in IL, and V phase is equal to, that is equal to VL by root 3 times. So these are the equations already we have seen in previous case. Okay, now let us concentrate our basic things, IL by I delta connections. Here how we are going to get the I3 here. You can see the current I star and I delta. So in I star we are going to VL by root 3 Z phase, and whereas I delta, so root 3 VL by I phase. So that by we are going to get it 1 by root 3, or we can say this IL star is equal 1 by root 3 of I line delta. Thus this method reduces the starting line current to 1/3. Okay, so voltage is reduced to 1 by 3, but current is reduced by 1/3. How? You can see here. Okay, now let us finalize the torque equation, starting torque to the full load torque as previously we discussed. So, as we seen that T starting by T full load, torque at starting by T full load, that is called x square into ISC by I full load whole square into SF, that is a slip at full load condition, where X factor by which the voltage is applied. Okay, similar to the previous case. So, in this case we are going to get it x square, x, what is the x value? So, x value is equal 1 by root 3 here, 1 by root 3. So, here x square 1 by root 3 square, that is equal 1 by 3. Okay, that is equal to I starting by I full load is equal 1 by 3 into and ISC by I full load whole square into SF as usual. So, previous auto transformer x square, here 1 by root 3 whole square. So, 1 by 3 times. So, that means the starting torque is equal to 1 by root 3 times of starting torque with a direct switching takes place. Okay. So, these are the relation similar to the previous case. So, with star delta starting, the starting torque is also reduced to 1 by that, you can see here relation. From the above expression, it is clear that the star delta starter is equivalent to an auto transformer starter in the a ratio of 1 by root 3, nearly 58% approximately. Okay. So, these are the some basic things regarding to the star delta starter. Then what are the advantages and disadvantages of this star delta starter? Let us see. So, what are the advantages here? So, low cost and simple as compared to the auto transformer. Auto transformer is a bulk in size. Here is a simple and low cost. And what are the disadvantages? Disadvantages are the torque too high, because here torque will develop a very high, causes a snatch. Torque, it may be produced very low, motor will stall. If it increases more, problem, it decreases less. The transition peaks up to the 20% of in motor can stall in transition. So, these are the some disadvantages, dear students. So, here as a technical words this one. So, no need to this one. Okay. So, these are the some advantages and disadvantages of star delta starter. Easy to operate. If you have provided the inside, the timer automatically take care of the when to change from star to delta. Okay. If any problems occurred, automatically cut off the supply to the motor. So, the easy, and there is no, at the same time you can say advantages. In case of other starters, we are going to provide the inside. In case of 3-phase 3-point starter, you can see that there is a resistance initially. If the resistance provided, the current passing through this one, then a heat mill takes place, that is the loss may be occurred initially. Here there is no loss takes place, there is no resistance component itself. So, there is no losses, simply we are using the connection changing from the star to delta. Okay. So, these are the regarding star delta starter. Let us summarize what we have seen in this class. So, after completion of this topic, the student will know about the following topics. 1. Connection diagram of star delta starter, the function and working of star delta starter, and starting control voltage equations in star and delta relations, and finally the relation between starting and full load torque equation as usual. Okay. So, these are the things we have covered in this class. Dear students, thank you for listening this star delta starter. Similarly, you can practice other starters also, that is the rotor resistance starter.